Let's play a game of Wordle. In this video, I'm going to try to introduce some programming concepts and show you what you can do with a little knowledge in regular expression, loops, and data manipulation. Okay, my starting word is going to be audio. Audio is a 5-letter word with 4 vowels. Among A, E, I, O, U, it has A, I, O, and U, right? Okay, the gray letters U, D, I, and O means those letters are not there, and we're trying to guess a 5-letter word. So let me go to my dictionary and try to pull out U, D, I, and O. This regular expression. It means I'm going to select all the words as long as any word matches the letter U, D, or I, or O. Okay, they are in the square bracket. Notice I'm going to delete all these words. So the remaining words doesn't have the letter U, D, I, or O. Okay, the letter A is in yellow, means A is present in the word but it's in the wrong position, so it cannot be in the first position. So I can again call regular expression. I use a caret sign. This is the caret sign followed by letter A. Caret sign means the starting of the word is A. So I'm selecting all the words that starts with A. Right, notice if it's starting from B, it's no longer selected. The other way is to say I'm going to select any word in the 0th position where it's equal to letter A. Right, 0 means the very first letter. Again, you get the same output, same selection, right? So 0 refers to the first letter. Okay, so I'm going to delete them as well. The letter A has to exist in a word, so I'm going to do a selection for all the words with the letter A. So notice some words are not selected, right? And then I'm going to do an inversion. So all these words highlighted does not have the letter A, do not have the letter A, so I'm going to delete them. Okay, now all words remaining have the letter A. So maybe I try the very first word, bagel. So again, the gray letters B and G does not exist in the word, so maybe the easiest way is regular expression, square bracket, B and G, close square bracket, select all words with B or G. Right, so all the words B with either the letter B or G will be selected, and I'm going to delete them. Okay. E and L have to exist, so I'm going to select for E, invert the selection. These are all the words without the letter E. I'm going to delete them. Repeat the same for L, invert the selection. These are all the words without the letter L. I'm going to delete them. L cannot be in the last position, so I'm going to select for L followed by $sign. This is a regular expression for the last letter, L and the N, right? So you have things like fetal, camel, and so on. Alternatively, we can write out the expression as well, like in the past. So the last letter, this is 4 words, 5 letters. So the first letter is 0, so the 5th letter will be 4, right? You can say this is equal to L. You get the same selection, right? As yet another way to do it is, instead of calling it element 4, we call it -1, right? This is negative indexing. You get the same answer. Okay, it's the same selection. So we're going to delete them because L cannot be in the last letter. A cannot be in the second position, so this time I'm going to just use regular expression. A dot means anything, so the very first letter can be any character, but the second letter cannot be an A. So I'm going to select all words where the second letter is an A, and then I'm going to delete it. So things like false, early, and so on. So clean. Let's try the next one. C-L-E-A-N. Clean. Clean, C and N cannot exist. I'm going to regular selection, square brackets, C and N, delete them. L, E, and A has to be in the middle. So I'm going to do a regular selection. First letter can be anything, followed by L, E, and A. Oh, there's only one word left. Pleat. P-L-E-A-T. Okay, that's great. So I'm now going to go over to do a little bit of programming and show you how they're related. Okay, so this is Python. Okay, Python from the terminal. You can get that from Unix as well. It looks the same thing. So for instance, right, you can treat it as a calculator, like 8 plus 8, you know, that's addition. It can do multiplication. 8 times 8 is 64. So basic arithmetic is there. It can do tests of equality. So for instance, you can say 8 times 8, is it equal to 64? This is a test of equality, 2 equal, okay? The space doesn't matter. You can have the space around it or not. You can test for inequality as well. For instance, if I say 8 times 9, is it greater than 64? The answer will be yes, because 64 is 8 times 8, right? So 8 times 9 would be definitely greater than 8 times 8. So that's a true. Okay. The next concept I want to introduce to you after arithmetic is this notion of list, right? A list is a collection of items. For instance, you can have, say, 4 digits like 8, 9, 6, 4, right? This is a list. Okay. Let me give a name to this list. Okay, let me just call it my list. A list is a very important concept because it's a concept that leverages the strength of computer, in the sense that the computer is really good with repetitive tasks. So, you know, if you were to have a list of items and then you want to perform the same type of function or calculation on every element of the list, it's easy to do so. Okay. So let me first explain how do you reference element of a list. So for instance, you can say my list, first element, which is element 0, because it's 0 indexing, is 8. The second element, 9, and so on, right? 2 and 3, right? And again, you know, this list allows for negative indexing, so you can put the like -1, will give you the very final last element as well. Okay, so a list, you can clearly sort it. You know, this from smallest to largest. Suppose you want to do a reverse sort, that's not a problem as well. You just reverse it and you get the opposite direction. A string, like a word, okay, let's say apple, you can also call a list function and say I'm going to kind of break it up into all the letters, A, P, P, L, E, for instance. This is a list, right, of the individual letters. Suppose you want it to break it up into the letters and you want all the letters to be unique. We have something similar, that's called a set. A set is, you know, the P no longer repeats twice, it only appears one. Okay, a list and a set are kind of similar ideas in the sense that they are both collection of items, but the list has a indexing and it has a certain order, right? Whereas a set is unordered, so each time you come out, the order is not certain, and there's no index, so you cannot say something like the first element or second element, because that's not supposed to be an order. So for instance, in a set, right, let me call this S. Okay, set, apple is called S. You can say, is the letter A in this set S? True, right? Is the letter P in this set? Yes, right? Is the letter B in this set? No, it's not, right? Sometimes it is useful to have a set where you actually kind of know the number of times each of this letter appears, right? That's like you want to count. and at the same time you don't really want it to be like a list. If that is the case, then we need to import a library, right? The library is going to be import, I think collections, sorry, it should be from collection import counter. So if you have this, you can call counter and apple, and this time you get something like a set, except that next to every element you have a certain number to say there are 2 P's here. There's one A, there's one L, and there's one E, right? So this is what we call a dictionary. Okay, let me just give it a name for this variable C. So for instance, you can say C, counter is a C, and say A, how many times does the letter A appears in apple? Well, 1 time. P, 2 times. What about the letter B? Well, it doesn't exist, so it should be 0, right? So that's counter. Okay. The last concept I want to kind of run over is this idea of a loop. Okay, so for instance, the way we write loops in Python is a little different from other languages. It's something like in the structure is something like for I in a list. So it could be like for I in my list, and usually you put it in a square bracket. So, and then before the for will be our expression. Means as you iterate through every element of the my list, you're going to have an element returned, and the element is going to be denoted by I. So let me kind of just call it I first, and maybe this will be easier. So this will give you back the original list. And suppose what we want to do is you say every element in this list I want to multiply by 2. Then you in this expression, which is on the left hand side of this for loop, you put 2 times I, right? Then it'll be 8 becomes 16, 9 becomes 18, 6 becomes 12, 4 becomes 8, right? You can do the same thing for strings as well. Strings are kind of treated like a list. So you can say like for I in audio, I, you break up into A, U, D, I, O, right? And of course you can then start doing things like you can say, is I a vowel, right? How do you test if it's a vowel? You can say, is I in A, E, I, O, U, for instance. The first letter A, yes. U, yes. D doesn't exist in the word A, E, I, O, U, right? So it becomes false. And then true and true. Suppose you're trying to count the number of vowels. Well, we can kind of call the sum function, right? Then you when you sum up a set of true and false, a list of true and false, the return value is essentially the number of times it is true. So essentially you can treat true as like equal to 1 and false being 0. This is called the Iverson convention. Is invented by the inventor of APL. Okay, now let's kind of go back to the dictionary again. Okay, I'd like to show you a few concepts based on what we have done. So for instance, right, we have a set of words in our dictionary. So let's kind of create a list first of all. So our list, right, is kind of like big, with you can kind of break it up into all the 5 letters. It's kind of a bit ugly here, so I'm going to make it a little kind of pretty. So 0, 1, 2, 3, 4. These are all the elements. 0 is the first letter, second, third, fourth, fifth, right? So a back is A, B, A, C, K, right? Then you have like about A, B, O, U, T, and so on, right? This, once you put it in this nice table, you can start doing analysis like what is the most common first letter, second, third, fourth, and fifth letter, and so on, right? If you're interested in doing that. Okay, let's delete that. So okay, the other thing I like to do is let's assume, okay, let's think about how do we find this idea about vowels early on. Right, vowels, like the number of A, E, I, O, U in one of each of this word. So one way you can do that is you say set of text. You kind of break up all this text into this component. So a bag will have A, B, C, and K. Remember, set is unordered, not in text. This comes in a random order. Once you have it in a set, you can start calling the function, right? Let's say we try to do a iteration around it. So the iteration around it is going to be let me see if I can make this smaller. So I'm going to try. Okay. So here essentially I'm trying to do a sum. I'm going to iterate through each letter of this word, and then for each of the letter in the word, I'm going to test whether it's in A, I, O, U. So and then I sum it up like what we did previously in the Python terminal, right? So these are like about has three of those vowels, because there's an A, there's an O, and there's a U. Right, let's kind of resort this from maximum to minimum. We can see that audio, the word I chose as the starting word, has 4 vowels, right? A, U, I, and O, right? And there are no other words that no other 5-letter words that has 4 unique vowels. Okay, so there are other words that has 4 vowels, but they are repeated, like eerie, E-E-R-I-E. The E is repeated 3 times. So I decided using set kind of exclude those words. Okay, let's end with one final data representation. So I'm going to start out with a list of this text again, and this time I'm going to break it up into the individual letter components. So this column A, for instance, a bag has 2 letter A's, A, B, A, C, K, right? 1 B, 1 C, 0 D, 0 E, F, 0 F, but there's 1 K, right? So and you see the same thing for everything else, like about, 1 A, 1 B, no C, no D, no E, and keep going on until O. It has 1 O, 1 U, and 1 T, okay, and so on. So this is also another kind of interesting data representation if you're interested to count particular letters, how many times it appears across the words. Okay, I think that's it for today. So this video is intended to just kind of like inspire you to motivate you to start learning little programming. Even though we use mainly Python in this video, most of the concepts we cover here, they are actually transferable to other programming languages. As an example, regular expression, or what we call regex, right, is available in Perl, PHP, JavaScript, Java, in many text editor for programmers like VS Code, Vim, Emacs, and even general purpose word processor like Microsoft Word. Okay, so anyway, if you like this video, please thumbs it up, like it, share it, and subscribe to the channel. Have fun with programming.